McCluskey algorithm. Typically what we do is we start with a given. So we're given a function, in this case of 4 variables, a, b, c, and d. And it's equal to some sum of canonical sum of products, and we'll put this into the shorthand notation. Let's pick 1, 2, 3, 6, 15, and throw in a 14 in there as well. So now what we'd like to do is perform some sort of rudimentary K-map. Always label your K-maps. Always number your K-maps. And I like to do this to do a verification. And it says here 1, 2, 3, 6, 14, 15, and all the rest are going to be 0. Now, each one of these elements is a min-term, also called an implicant. There's no difference except in the nomenclature. And if you see an element like this which can be combined, that becomes a prime implicant. And so we would label that particular loop as A, B, C. In this particular loop in here, A prime, C, D prime. And this loop here, A prime, B prime, and then D. That's simple enough. But now if we wanted to try and do the same exact thing with Quine-McCluskey, what we would do is we would start with the Hamming weight. The radix equals 10 and the radix equals 2. And for radix equals 10, which is what we can fill in first, we have 1, 2, 3, 6, 14, and 15. For radix equals 2, we just fill in the binary. For the Hamming weight, we count the number of zeros. And then we group by the Hamming weight. That'll be group 1, group 2, and group 3. And we call this column 1. And then we do a column 2 with combinations. And check off as we go. Actually, now that I think about it, that should have been -1. There we go. As the 1 and the 1 combine and the 0, sorry, the 0 and the 1 combine and the 1 and the 1 remain. Then we do 0, 0, 1 dash. And then we do 0 dash 1 0. We can't combine 0, 0, 0, 1 with 0, 1, 1, 0 because there's 2 bits of difference. And so then we go on to the next list of comparison, comparing this against that. Too many bits of difference. Comparing this against that. we see, aha, there's a bit of difference in the most significant bit, so it becomes dash 1 1 0. This gets covered, and then we compare this against that, and we have 1 1 1 dash, and that has coverage. So now we've got coverage in all the implicants. If these can't be combined any further, they become prime implicants. Let's see if that's true. I can't combine this any further, so this becomes a prime implicant. Can't combine this any further, prime implicant. Can't combine this any further, prime implicant. That's a prime implicant, and that's a prime implicant. Isn't that interesting? Moreover, we can identify the numbers that are associated with this. 0, 0, 0, 1 would be a 1. 0, 0, 1, 1, that would be a 3. 0, 0, 1, 0, that would be a 2. 0, 0, 1, 1, that would also be a 3. 0, 0, 1, 0, that would be a 2. 0, 1, 1, 0, no, that's a 6. 0, 1, 1, 0, that's a 6. And 1, 1, 1, 0, that's 14. 1, 1, 1, 0, that's 14. And 1, 1, 1, that's 15. Now we go to the implicant chart, and we write out across the top 1, 2, 3, 6, 14, and 15. And then we put an X when there's coverage under any one of the min terms. And this says 14, 15. And now what we do is we look for the essential prime implicants, and that's the ones with solo elements in the columns. And that means this one here, which means we have coverage along in here and coverage down here. And now we have to find a way to get coverage on this one here. That looks like a good one, because that gives us nice coverage. And then we do a coverage on this one here, and that gives us nice coverage. And there we have it. So now it looks to me like we're going to have, in final cover, A, B, that's C, and then D, and the first two are prime, or A, B, C, D. B is left out, so it's A, C, D. And we have prime for A and prime for D. And we have A, B, C. Now we compare. Here's the ABC here and here. Here's the A prime C D prime here and here. Here's the A prime B prime D. Now, this looks like a mistake. That says 0, 0, dash 1. Well, that does look right. 1 and 3. 1 and 3 should be... Oh, they are the same. A prime, B prime, D. They are the same. I don't know why they... Oh, did I write D? That's supposed to be a B. Huh, worked out. So this is A prime, B prime, D. That's A prime, B prime, D. They are the same. So these three terms match these three terms, and look, they're even in the same order, but that's just a coincidence. And there you have it. Quine-McCluskey in all its glory. Thank you very much.